Teleportation is a cool concept that we often see in the movies. Star Trek is probably one of the most well-known examples of the teleportation of people. Everybody knows the phrase, "Beam me up." The characters would disappear from their starter location and appear at their destined location with just a simple push of a button. So, the teleportation is done through a machine or with the help of super advanced tech. In other cases, a character, such as a superhero, possesses the ability or superpower that allows them to teleport to almost anywhere on the planet. To me, and probably a lot of people, this would definitely be the ideal and preferred method of transportation, if possible. And that's the key word, if. Because as it currently stands, teleportation is only science fiction. Or is it? The only scientifically confirmed method of teleportation is something called quantum teleportation. Let's look at a definition. Quantum teleportation is defined as a technique for transferring quantum information from a sender at one location to a receiver at some distance away. While teleportation is commonly portrayed in science fiction as a means to transfer physical objects from one location to the next, quantum teleportation only transfers quantum information. So, with quantum teleportation, a person cannot appear out of thin air from one location to another like the transporters in Star Trek. Sorry guys. Then how does quantum teleportation of information work? Here's the rundown. When two particles, such as photons, are created together and then separated, they can transmit information between each other without a physical connection, even though they are at great distances apart. Albert Einstein famously called this spooky action at a distance, which would later become known as quantum entanglement. Now let's say the photons are arranged in a particular order and then transfer their exact quantum condition or state on the other particles that are further away. While the particles themselves do not move, only their state does. Regardless of the distance, if you measure the state of each of the separated photons, it would be exactly the same wherever they are. Scientists were able to test this theory using computers in 2016 at a lab in China. They created two entangled photons. One stayed on Earth while the other photon was sent to a satellite in space. When they measured the one on Earth, it would move exactly the same as the one in space, even when there was no physical connection between the two. They were able to measure the maximum distance needed for the entangled photons to remain linked. This distance is currently 870 miles or 1,400 kilometers. Movies like Star Trek and superhero characters like the Nightcrawler make teleportation seem extremely fun and convenient. Unfortunately, it remains a fictitious representation. The truth is, teleportation can get very dark pretty fast. Let's say we apply the same principles of quantum teleportation to people. For it to work, there would need to be two bodies, one at your starter location, such as your bedroom, and then another body at your destined location, let's say Hawaii. The original body has all of your consciousness and memories, and only these would be transferred over into the new body in Hawaii. But because of something called the no-cloning theorem, your original body would still have to be destroyed and all the information extracted in order to construct a duplicate of you in the new body. Ouch. And then we are left with the question, is the new body really the same person? So as fun as it might sound to skip over the cramped seating on the plane and to magically appear in Hawaii, is it worth destroying your original body and consciousness every time you don't want to have an unpleasant flight? My name is Ryan Rowe, and I'll catch you later.